In this example, we are going to anti-differentiate secant of x. Now, it turns out that this is actually a commonly encountered antiderivative, yet it doesn't fit any of the guidelines provided in our tables for evaluating things like, say, tangent to a power, secant to a power. Instead, evaluating this integral requires just a bit of ingenuity here. What we are going to do, and it's not maybe immediately obvious why we are going to do this, but we are going to multiply by 1 in a somewhat fancy way. A couple ways we can always algebraically manipulate an integrand would be to add 0, that doesn't change anything, or multiply by 1. And here we're going to multiply by 1 as secant x plus tangent x divided by secant x plus tangent x. And in a moment we'll see why we are doing this. So now if we go ahead and just distribute this secant through the numerator, we'll have secant squared plus secant tangent in the top. And in our denominator, we're still going to have just the secant plus tangent. And seeing an integrand of this form, one thing we could certainly think about here is doing a substitution. And in order to do a meaningful substitution, we want to pick u to be an inside function, so maybe the entire denominator. And notice the derivative of secant is secant tangent, and the derivative of tangent is secant squared. So the reason we've multiplied by this secant plus tangent over secant plus tangent is it leaves you in this ideal situation to do a u substitution. So u is secant plus tangent, then du is secant tangent plus secant squared. And then that entire quantity is multiplied by dx. So our denominator becomes du, and then everything in the top, including the dx, becomes a du. And what I meant is everything in the denominator becomes u. So upon doing this substitution, this turns into an extremely reasonable integral. So the antiderivative of 1 over u is natural log absolute value u. And the last thing we need to do is just resubstitute in. So we have natural log of the absolute value of secant plus tangent. And as I mentioned, this antiderivative of secant is something that's commonly encountered. And so what I recommend is that we just make sure that we know this formula. Every time we encounter it, we don't have to go through this work of multiplying by 1 in a fancy way and then doing a substitution. But instead, we've done it once, so when we encounter it again in the future, we will just go ahead and use this formula.